Hello, love buttons. Welcome to section 1.5 about graphs and graphing utilities. We're going to start with looking at pictures, tables, actually graph, and then we're going to whip out our calculators. So please have your graphing calculator next to you. I'm going to give you the buttons we're going to be pressing, and then in class, I'll actually show it in detail if you are a little confused. So let's jump in. As you can see, a graph of an equation is two variables is a set of all points with coordinates that satisfy the equation. Man, I couldn't butcher that anymore. For example, here is the graph of y equals 3 minus 2. Start at negative 2, slope of up 3 over 1, up 3 over 1, positive slope. Here's my x-axis, y-axis, voila. You also could look at an equation in a table. You can actually do this on your calculator by going to second table. And you'll see these once you type this into your y equals. This is the same thing as y equals 9/5 x plus 32. If you prefer looking at x and y versus c and f, it's the same idea, so you can get kind of a graph in your mind. Let's see what we got here. We're going to graph example 1. This is in standard form, 2x minus 3y equals 6. By all means, you can convert to y equals mx plus b, which is what the example above looked like, and you can graph from there. Love that way. Since it's also in standard form, I can just find the intercepts, x and y intercepts, and then graph them. If that's what you want to do, let's do it. First one I'm going to find is my x-intercept. So I'm going to draw out a nice xy table for myself. The 2 points I'm trying to find is when x is 0, and the other point is when y is 0. Okay, let's start with my x-intercept. So that means y is 0. So 2x minus 3 times 0 equals 6. And I'm going to solve this. Negative 3 times 0 goes away. So 2x equals 6, x equals 3. That goes right here. When y is 0, x is 3. That's your x-intercept. Finding your y-intercept, that's when x is 0. So take your original equation. This time plug in x is 0. 2 times 0 makes it go away. Negative 3y equals 6. Y would be negative 2. Graphing those points, 0, negative 2, 3, 0. I then can connect it and cover the entire graph. And voila. That would be the same graph if you were to transfer it into y equals mx plus b. Maybe try that as an exercise. Part B is a parabola. I know it's a parabola because of the square right here. Many ways to do this one. You can find the vertex and graph from there. You can find the y-intercepts, x-intercepts. As long as you get enough points to see the graph, that's what I care about. So I'm going to start, again, with my xy table. I'm going to try to find my x-intercept, y-intercept, and maybe another point along the line. Let's see what we get. So starting off, if y is 0, oh, look at that. It's just a nice quadratic that I can solve. I'm going to factor these. Good thing we learned about factoring. What adds to negative 2? Adds to negative 2, multiplies to negative 8. 0 product property leaves me with 4 and negative 2. So actually, when y is 0, there's 2 options. You will get negative 2 and you'll get 4. Those are two x-intercepts. Y-intercept means x is 0. That term goes away. That term will go away. I'm left with just y equals negative 8. Graphing these points, negative 2, 4, then negative 8. Oh man, falls off. That's okay. Now, we have to be aware that this point down here is not actually the vertex. It's not where the graph's going to perfectly change shape, because the x-intercepts, the midpoint will be where the vertex lands. So we count maybe 2 in, 2 in. Oh, look it. This is the midpoint. 3 from both. So I know on this line, this axis of symmetry, we can be specific, that's where the vertex is going to fall. So why don't we just find that for good measure? The vertex. I know it's going to be when x equals 1 because it's the midpoint of my x-intercepts. Well, if x is 1, I can just plug it in. 1 squared minus 2 times 1 minus 8. 1 minus 2 minus 8. Negative 9. And that's my point. 1 comma negative 9, which actually falls right here. You now can put your parabola up, put your parabola through your y and x intercepts, and voila. That's your parabola because it has a squared term. Now use your graphing calculator to graph these, and then find the x-intercepts. So, this is calculator. Grab them out. I'm going to do this through the video, but then in class, I will for sure walk us through it again. When we graph, these are the steps we're going to follow. Do it in blue, less scary. So when we graph, you're going to go to your y equals. Type in your equation. To find the x-intercept, the buttons you're going to press are second, trace. Trace is on the top bar of your calculator. And we're going to find the 0. So you're going to choose the option that says 0. And then you'll have to deal with right, left bounds, which is using your cursor, move to the right, press enter. It will ask you for left bound. Move to the left, press enter. You have to press enter one more time to guess. And then there will be your x-intercept. If you did it correctly, you should get the x-intercepts to be negative 1.85 and 1.35. If you did not, try to look back at these buttons, but I will explain it in class. To find your vertex, so what we did by hand in the last problem, again, you press second trace. This time you have to pick max or min. Well, in this problem, think about the shape. Because this is a positive number, the graph's going to go up, which means I need to find the minimum point. So in this case, I'm making the decision. It is a minimum. Again, you'll do that right-left bound. And then it should pop out your answer once you press enter 3 times. The vertex should be negative 0.25, comma negative 5.13. Sometimes we'll have a graph like B, where it's not just a normal parabola. Instead, it should actually be something that looks like this. If we go correctly and do graph y equals, let's move that over. Graph y equals, you should get that shape. If you don't, please zoom out. So go to window, zoom out, and hopefully you'll see then the whole shape. Practice finding the x-intercept using the same buttons that we did over here. So again, I'll just copy it over. If you did it properly, your x-intercepts should be 3 of them because they're right here, here, and here. Those 3 points should be negative 1.37, comma 0, 0.37, comma 0, and actually 1, 0. A nice one at the end. Now, instead of finding a true vertex here, we kind of have two. This one is a max, and this one's a min. You'll do the same steps like we did right here. But based on the fact if it's a max or a min, you have to make that decision based on your point. And make sure you just do your right bound and left bound for 1 point at a time. You will have to do it twice. So if here's my point, right bound would be over here, left bound over here. Your answer should be your max. So that point on the left star should be negative 0.71, comma 2.41. And the min should be 0.71, negative 0.41. If you're able to get these, amazing. If not, we will talk about it in class. I'll pull up an actual calculator. We'll do it together. But at least you have the idea and the buttons. If you have questions, let me know.